Hi everyone. In this video, I'm going to share with you all a very unique and interesting question where we had to determine for the given two events A and B if they are independent or not. And this question was suggested by a lot of students on our WhatsApp group, and that is why I'm creating the video for the same. So, a quick update for you guys before we move any further in this video. I'm documenting all the challenging questions in the Google Sheet whose video solutions I'm posting on my YouTube. So currently I'm just starting out, so that's why you're not seeing a lot of things over here. But as we go ahead in the upcoming few months, you will be seeing that you will be having a lot of questions to practice, which are only challenging or of a different kind that you might have not seen in the previous year's past papers. So if you want access to this kind of Google Sheets, both the links for the physics and the mathematics are present in the description of the video. You can check it out from there. Wishing you all the very best, guys. Let's move on to the video. By the way, this question appeared in the February-March 2023 of the Cambridge examinations. This is paper 5.2 and the fifth question of this paper. So let's get started with the question. Marco has four different boxes labeled as KLMN. He is going to place them in a straight line in the order of KLMN, where K is going to be on the left side. Now Marco has four different color marbles. One is red, one is green, one is white, and one is yellow. He is going to place a single marble in each box at random. And the events A and B are defined as follows. Event A is such that the white marble is placed either in the box L or M, and event B is such that the red marble is always to the left of both the green and the yellow marble. Now we have to determine whether or not the events A and B are independent. So please pause the video over here if you haven't already tried this question and come back once you are ready. And then I'm going to go through the examiner's comment for this specific question and then move on to the solutions. So yes, you can pause the video over here. So welcome back guys if you did give it an attempt. The first comment by the examiner is that not a lot of students were able to make a single attempt to this question. So I can understand that because even the students on my WhatsApp group were complaining that they were not even able to understand what's really given over here. It's that unique. They haven't seen something like this in the past papers. So just imagine the pressure for the students who are appearing in this particular paper. They'll just be very much confused about, oh my God, what kind of question is this? And probably didn't give any kind of attempt. So that's what has been highlighted over here. But then for the students who did give it an attempt, a lot of them were able to calculate the probability of A correctly, but then there was little to no progress seen for the probability of event B. And there were two of the majority of the mistakes that was highlighted by the examiners in the examiner report in order to calculate the probability of B. So some of the students forgot that Y and G could swap the places. And the second mistake is some of the students also thought that Y and G are only in the fixed boxes like M and N. So yes guys, these were the two of the most common mistakes seen while calculating the probability of B. And because the probability of B was not correctly calculated, there will be mistakes in calculating the probability of A and B happening together as well. But now let me show you how to solve this question. So event A states that the white marble is either in the box L or M. I have drawn both the possibilities over here. Now for the possibility where my white marble is in the box L, I am having remaining three of the other boxes and three of the other colored balls which I can arrange over here. So what are the total arrangements such that W stays in the box L, but I can arrange the remaining other color balls in the three empty places? It's going to be 3 factorial V's. So 3 factorial V's becomes the favorable outcome of the event A. But then because we are trying to calculate the probability, I'll also need to figure out what are the total possibilities where I can arrange 4 color balls in 4 empty places. It's going to be 4 factorial V's. So out of this many possibilities, these are the possibilities where I can say that W stays in the box L and the other color balls could be in the remaining places. Now the same calculations can be repeated for the second part, that is the W stays in the box N. Again, I can say that the favorable outcomes are 3 factorial B's to arrange other balls keeping W in the box N out of the total of 4 factorial possibilities. And if I just add them together, I will be able to calculate the probability of event A as 1 by 2. So that's my answer for the probability of event A. Now let's move on to the probability of event B. So for the event B, we are going to have the red marble placed to the left of both the green and the yellow marble. There is no restriction for the white marble. My white marble can be anywhere. but my green and yellow marble will always be towards the right of the red marble. Only in that case we can say that red is towards the left of both of them. So here are the two possibilities that I have marked. For the first possibility, I have said that let's say R is completely towards the left, that is in the K box. So now because R is fixed, I am left with the other three color balls, that is green, yellow and white. I am now having these three colored balls and three empty places to have total possibilities. So what is the favorable outcome over here? It's going to be 3 factorial ways over how many total possibilities? 4 factorial ways. So this calculation is very similar to what we have done over here. But then there is also another possibility where my red marble could be placed in the box L. Now I know that my red will always be towards the left of green and yellow. So I know that green and yellow can either be in the M and N, it cannot be in the box K. So in the box K, it's 100% of white marble. And then because I'm having white and the red fixed, I'm just having two other colored marbles to arrange in the two boxes. So the favorable outcomes over here is going to be 2 factorial out of the total outcomes as 4 factorial. And therefore, over here, if I calculate my probability of B, I'll need to add them together. I'll be getting the value of 1 by 3. So yes, that's how you calculate the probability of event B. So now that we have calculated the individual probabilities of event A and event B, I'll just need one more thing to prove that event A and B are either independent or not. And that thing is the probability of event A and B happening together. So now let's try to calculate that. So just a quick recap that my event A is that my W is fixed inside either of the L or M boxes. And my event B is that my R is always towards the left of the green and yellow marbles. And based on both of them happening together, I have got two different possibilities. In the first possibility where my W stays inside the box L, it means that my R must be inside box K. Only then I can say that my R will always stay towards the left of the yellow and the green marble. So now for the yellow and green, what are the possible arrangements? It's going to become 2 factorial ways. So the favorable outcomes over here such that my W stays in L and R is towards the left of green and yellow is 2 factorial ways. Out of how many total possibilities? That is 4 factorial ways. That is unchanged. And now moving on to the second possibility where my W is fixed in the box M. Think about where can I place my R such that it is always towards the left of the green and yellow both. So again, you will be able to think that R must be placed in the box K. It's correct. So now again, you are having two empty places to arrange your green and the yellow marbles such that W is fixed in the box M and R always stays towards the left of green and yellow. So 2 factorial ways to have that outcomes out of the 4 factorial ways. And now if you just sum both of them, you will be having the probability of A and B happening together as 1 by 6. So now that we have calculated the probabilities of A, B and A and B happening together, I can say that A and B will be independent events if the individual probabilities, if you multiply them, comes out to be equal to the probability of both of them happening at the same time. So probability of event A is 1 by 2, probability of event B is 1 by 3. If you multiply 1 by 2 with 1 by 3, it's going to be 1 by 6, which comes out to be equal to 1 by 6 that we got as the probability of A and B happening together. Therefore, we can say that the events A and B are independent events. So that is how you solve this question, guys. So that's it about this video, guys. Please let me know in the comments if this video was helpful for you or not. And don't forget to click on the like button if it was useful for you. So yeah, I'll be seeing you in the next video.